As part of the lesson resources that you've downloaded, under Spam Data 01 Processing, there's a folder called Word Cloud Resources. And there you should see a whale-icon.png file. And this is going to be our mask that we will project the words from the word cloud onto. If you scroll back up in the notebook to where we've got all our constants, we can add another one here. Let's add the relative path to this PNG file. So I'm going to add a new line, and here we'll add a constant called whale_file and set that equal to what it says in the previous string. At first, save us some time typing. The first two bits will stay the same. It will still be Spam Data 01 Processing, but after that /, we have to write word cloud _ resources / whale-icon.png. This bit here needs to be the relative path that points to our whale-icon.png file. As always with these things, everything's case sensitive. Now, before we scroll back down, let's go up to our notebook imports and import another tool. This will be some functionality from the PIL package. So from PIL, all caps, import image. PIL is short for Pillow. Pillow is the name of a package that will help us with image manipulation and processing. Pillow can actually do quite a lot of things, like pixel manipulation, image blurring, or smoothing, or adding text. We're going to be using it to convert our starting image of the whale to grayscale, and then to an array of RGB values. And the reason for that is that Word Cloud has some very specific requirements as to what kinds of images can and cannot be used as a mask. And also, it's quite particular what kind of format the mask is in. And that's why we need to do a little prep. Also, I suspect that at one point you want to use your own custom masks with Word Cloud at some point in the future. So it's a good idea to have seen this workflow of the image preparation once before. In fact, let's take a look at Word Cloud's requirements. If I scroll down here and hit Shift-Tab on my keyboard to bring up the quick documentation, I can see that there's a parameter called mask. By default, it has the value none. And scrolling down, we can take a quick look at a more detailed description. And this reads, if not none, gives a binary mask on where to draw words. So the mask will specify the location of where the words are drawn on the canvas. Further down it says, all white entries will be considered masked out, and all the other entries will be free to draw on. And the format that we need to supply this mask in is an ND array, an n-dimensional array, like one from NumPy. Now that sounds a little strange, right? Why would we provide an array? And the reason is that Word Cloud actually expects pixel by pixel information on the image in this array format. And when I say pixel by pixel information, what I really mean is pixel color. Because what the Word Cloud code cares about is if it's dealing with a white pixel or a pixel in another color. The way that we will be providing this pixel color information is in RGB format. RGB stands for red, green, blue. We're already acquainted with color hex codes from previous lessons, so this time we'll use RGB to mix things up a little bit. The RGB format is particularly relevant because it relates very closely to how colors are shown on your TV or your phone screens. If you were to take a magnifying glass and go up really close to your phone, you'll actually see tiny little red, green, and blue LEDs. With RGB, you essentially supply three values, namely how bright each of these little LEDs should shine. The RGB values themselves have a scale between 0 and 255. If all the numbers are on 255, then we get pure white. If all the numbers are on 0, then we get pure black. And with any combination between, we get all the other colors. Back in our Python code, we now know that our goal is to get an array of RGB values to our word cloud. The first step will be opening the image file. You'll recall that we've added a constant up top that points to the whale-icon.png file. So we can use Pillow's image.open and then supply the relative file path, our whale_file, to the open method. In fact, let's say icon equals image.open whale file. Step 2 will be creating a new blank image object from Pillow. So again, we'll use image.new, and then we'll supply 3 arguments. The first of which is the mode, and this will be RGB. The second of which will be the size. So we're kind of setting the size of our canvas here. And I'm going to set that equal to icon.size, so the same size as the whale image. And the third thing is I'll set a base color, and that will be equal to 255, 255, 255. So this is a tuple of 3 integers, and they correspond to the red, green, and blue values. With all of them set to 255, we get white. I'll store our blank canvas in a variable called, say, image_mask. Now what I'll do, I'll take our image mask and put a dot after it and say paste, parentheses, icon, box equals icon. What this will do is it will paste the picture of our whale onto our blank canvas. And the reason we're doing this is because now we can easily convert our image mask to an array of RGB values. This is why we went through all this trouble. So I'll say RGB_array is equal to numpy, so np dot array, parentheses, image_mask. This is the key. This converts the image object to an array. And with that in hand, we can supply the mask argument to our word cloud. So we'll see mask is equal to RGB array. Now let's hit Shift Enter and see what we get. Name NP is not defined. Looks like we forgot to import numpy as NP. Let's go to the very top on our notebook imports, and indeed we're missing it. So this shall not do. Any self-respecting Python notebook needs to import numpy, right? So let's add import numpy as NP and hit Shift Enter. Now we can refresh this cell and see if it runs. Giving it a little bit of time, we now see our words superimposed on the whale. Brilliant. So this is really cool, but I think we can style this a little better. And the way we're going to do that is we're going to supply some more arguments to our word cloud here. In particular, I'm interested in changing the background color here, and I'm also interested in changing the color of these words. And we can do that by supplying something called a color map. Also, I want to play with this max words parameter here, which is currently set to 200. Let's see what happens when we change this to, say, 50 or 400. But the very first thing I'm going to do is change the size of this image. And this is good old matplotlib's plt.50 figure method that I'm going to call here. So figure, parentheses, fig size, square brackets, 16, 8. I think that will do nicely and make it a little larger and easier to see what the styling changes are going to look like. So here's our whale now. Let's change the background color to white. I'll add a comma here, change the background color to single quotes, white, and hit Shift Enter. Now this is starting to look a lot better in my opinion. But let's play with some of the other parameters as well. Before we add those though, I'm noticing that this line is getting a little long. So instead of chaining this method call here, I'm gonna come down here, hit enter, and say word cloud dot generate on a separate line of code. Here, after background color, I'll insert a comma, hit enter, and then change the max words to say 50, and update our graphic. So that's a very different look, right? On the upside, this image was generated a lot faster than the other ones. But on the downside, I can't really tell that this is a whale anymore, because a lot of the edges and so on depend on smaller words being present to flesh out this image. So what I'll do instead is change this max words argument to 400 and refresh the cell. At this point, our code will have taken a little longer, but we get a much more beautiful word cloud with all the small words on the perimeter of this mask. But if you recall, what's actually determining the location of where these words are drawn on the canvas is this RGB array. If we take a closer look at this RGB array and hit Shift Enter on it, we see that it looks something like this. Now, that doesn't tell us a whole lot, maybe. A better way to look at it might be RGB.shape. And there we see it's 1024 by 2048 by 3. The reason we see those numbers here is because the whale icon itself has a width of 2048 pixels by 1024 pixels. And the 3 is for the red, green, and blue RGB values. In other words, this array has pixel by pixel information on the color. If we take our RGB array, we can actually pull up a particular pixel. So if I say, for example, 1023, 2047, then I can see what the RGB values are for this particular pixel. Given that this pixel is white, the word cloud will not draw in this area. But let's take the pixel at, say, 500 and 1000. Here we see the values 000, meaning that at this particular location in the image, the pixel is black. So word cloud is free to use this particular pixel to draw on. Now, one of the nice things about Matplotlib is that we have access to these wonderful color maps. And we can play with the styling of our words by, say, providing one of these color maps as an argument. There's quite a few to choose from. We could go with plasma, we could go with blues or greens or oranges, but one that I found that works particularly well, I think, for the whale image is a color map called Ocean. Refreshing our cell, our whale will now start looking something like this. And I think thematically, this color map seems to work rather well. Having worked a little bit now with the NLTK resources and our word cloud code, I want to throw it over to you. I want to propose a challenge. I'd like you to use the skull image in the lesson resources as a mask to create a word cloud for Shakespeare's play Hamlet. The skull image that I've included looks like this. So have a go at this and have a play with different color maps and different number of maximum words to make this look good. And you can find Shakespeare's entire play under Gutenberg and then Shakespeare-hamlet.txt. This is something that we've downloaded as part of the NLTK resources. The file is actually in the same folder as Melville's Moby Dick. If you're particularly brave, then you can try and tackle the Hamlet play in the form of XML, as opposed to a TXT file.